In this module, we will be studying about the classification and nomenclature of haloalkanes and haloarenes. Part 1. A haloalkane molecule is formed when a hydrogen atom in an alkane molecule is replaced by a halogen atom. Some typical haloalkanes are illustrated here. This class of compounds is also called alkyl halides. Haloarenes are formed when a hydrogen atom in an aromatic compound, such as benzene, is replaced by a halogen atom. These compounds are also called aryl halides. Many organic compounds that contain halogens occur naturally. Both synthetic and naturally occurring halogenated organic compounds have important uses in medicine and research. Chloramphenicol is a naturally occurring substance produced by soil microorganisms. As you can see in the structural formula, it contains 2 chlorine atoms. Chloramphenicol is used as an effective drug in the treatment for typhoid fever. The thyroid gland, a butterfly-shaped gland at the base of your neck, produces the hormone thyroxine. Notice the 4 iodine atoms in the chemical formula. A lack of dietary iodine can lead to a deficiency of this hormone, which can eventually lead to goiter. Chloroquine, a synthetic compound, is used for the treatment of malaria. Halothane is used as a general anesthetic during surgery. These compounds are used in industries as solvents for relatively non-polar compounds and also as starting material for the synthesis of a variety of organic compounds. Haloalkanes and haloarenes can be classified in several ways. One way is to classify them based on the number of halogen atoms. Chloroethane, a monohaloalkane, and chlorobenzene, a monohaloarene, each containing 1 halogen atom, are shown here. Dihaloalkanes and dihaloarenes have 2 halogen atoms in their formulae. Trihaloalkanes and trihaloarenes with 3 halogen atoms are also known to exist. Based on the heptization of the carbon atom to which the halogen atom is bonded, monohalo compounds are classified as alkyl halides, allylic halides, benzylic halides, vinylic halides, and aryl halides. In alkyl, allyl, and benzyl halides, the halogen atom is attached to an sp3 hybridized carbon atom. On the other hand, in vinyl and aryl halides, the halogen atom is attached to an sp2 hybridized carbon atom. We'll start with the alkyl halides or haloalkanes, which have the general formula Rx. R here represents an alkyl group. In these compounds, the halogen atom is bonded to an sp3 hybridized carbon atom. The homologous series of alkyl halides can be represented by a formula CnH2 n plus 1x. Based on the nature of the carbon atom to which the halogen atom is attached, The alkyl halides are further classified into primary, secondary, and tertiary. In primary alkyl halides, the halogen atom is attached to a primary carbon atom. For example, ethyl chloride is a primary alkyl halide. In secondary alkyl halides, the halogen atom is attached to a secondary carbon atom. Isopropyl chloride shown here is a secondary alkyl halide. In tertiary alkyl halides, the halogen atom is attached to a tertiary carbon atom. For example, in tertiary butyl chloride, the chlorine atom is attached to a tertiary carbon atom. You need to be able to recognize allylic carbons. Allylic carbons are carbon atoms bonded to a carbon atom that is doubly bonded to another carbon atom. As the illustration here shows, allylic carbons are one position away from a double bond. Allylic carbons are sp3 hybridized. Allylic haloalkanes have halogen atoms attached to allylic carbons. In benzylic halides, the halogen atom is bonded to a carbon atom with sp3 hybridization that is linked to an aromatic ring. In primary benzylic halides, the carbon attached to the halogen has only one carbon-carbon bond. Here are secondary and tertiary benzylic halides. In a secondary benzylic halide, the carbon attached to the halogen atom is bonded to two other carbons. In a tertiary benzylic halide, the attaching carbon is bonded to three other carbon atoms. It will be helpful in your chemistry studies if you can identify vinylic carbons or alkynyl carbons, as they are sometimes called. Vinylic carbons are sp2 hybridized and are double bonded to one carbon atom. The vinylic carbons in two different molecules are shown in the illustrations here. Vinylic halides have a halogen atom bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Two examples of vinylic halides are shown here. In aryl halides, the halogen atom is bonded to an sp2 hybridized carbon atom of an aromatic ring, as illustrated here. In this module, we will be studying about the classification and nomenclature of haloalkanes and haloarenes. Part 2. Learning the proper nomenclature of organic molecules is very important, and it takes a lot of practice. Many compounds have common names as well as systematic Iupac names. The common name of alkyl chlorides can be found by giving the name of the alkyl group, followed by the halide. In the Iupac nomenclature system, they are named as halo-substituted hydrocarbons. Let's write the Iupac name of the given molecule. The longest continuous carbon chain has 4 carbon atoms, and hence, the root word is but. Since the longest carbon chain is saturated, the primary suffix is -ane. Thus, the name of the parent carbon chain is butane. We then need to identify the substituent and its location. For this, we need to start numbering the carbon chain from the end nearer to the carbon atom to which the substituent is attached. We see that the carbon atom with the substituent chlorine is in position 1. Thus, the name of the given compound is 1-chlorobutane. Let us find IUPAC names for these two molecules. The IUPAC name for the molecules on the left is 2-chloro-2-methylbutane. It is a tertiary haloalkane, as the chlorine is bonded to a carbon linked to 3 other carbon atoms. The IUPAC name for the molecules on the right is 3-chlorohexane. It is a secondary haloalkane. Notice that the chlorine is bonded to a carbon linked to 2 other carbon atoms. Now let us draw the formulae for the compounds as shown here. The illustration on the left gives the trans isomer of 2,3-dibromobute-2-ane. Shown here is the cis isomer of 2,3-dibromobute-2-ene. The common name for haloarenes give the name of the aryl group followed by the halide. Common names may use the prefixes ortho, meta, and para to indicate relative spacing, 2, 3, or 4 carbons between the halogen atoms. In IUPAC nomenclature, haloarenes are named as substituted arenes, listing the location and type of the halogen atoms. Let's work through some practice problems together. What are the IUPAC names of these compounds? All 3 molecules are benzene derivatives. Remember, if more than 1 similar substituents are present, then we must give the location of each and include prefixes indicating the number present. The common and IUPAC name for molecule A is chlorobenzene. Molecule B is often called meta-dichlorobenzene. Its IUPAC name is 1,3-dichlorobenzene. The common name for molecule C is symmetrical trichlorobenzene, while its IUPAC name is 1,3,5-trichlorobenzene. Dihalogenated compounds with the same type of halogen atoms can be classified based on whether the halogen atoms are on the same or adjacent carbons. If the 2 halogen atoms are bonded to the same carbon atom, then it is called a germinal dihalide. Germinal dihalides in the common system are called Alkylidine Halides. In the IUPAC system, they are named 1,1-dihaloalkanes. Thus, the molecule shown here can be called ethylidine chloride. Its IUPAC name is 1,1-dichloroethane. If 2 halogen atoms of the same type are bonded to adjacent carbon atoms, it is called a vicinal dihalide. Vicinal dihalides in the common system are sometimes named alkaline dihalides. In the IUPAC system, they are named 1,2-dihaloalkanes. For the molecule shown here, the common name is ethylene dibromide. Its IUPAC name is 1,2-dibromoethane. Here are some additional practice problems. Try to name molecules A, B, and C on your own before proceeding. Molecule A is 1,1-dichlorocyclopentane. Molecule B is correctly named 2,4-dibromopentane. In this molecule, you will get the same name whether you start counting from the left or the right. Molecule C is 7-bromohept-1-ene. You might see this written as 7-bromo-1-heptene. Using earlier IUPAC guidelines, the double bonds take priority over the halogen atom. So, carbon number 1 is at the far right. Practice is the key to learning organic nomenclature. Here are 2 problems to try on your own. What are the common and IUPAC names of these compounds? Vinyl bromide and allyl chloride are the common names of these molecules. What are their IUPAC names? The common name of compound A is secondary butyl bromide, and its IUPAC name is 2-bromobutane. The common name of compound B is neopentyl bromide, and its IUPAC name is 1-bromo-2,2-dimethylpropane. The common name of compound C is tertiary butyl bromide, and its IUPAC name is 2-bromo-2-methylpropane. The IUPAC name for vinyl bromide is bromoethene. No number is necessary for the possession of the bromine atom. Whichever carbon atom it is attached to must be the first carbon. The IUPAC name for the allyl chloride is 3-chloropropane. Because of the double bond, the leftmost carbon is at position number 1. Let's practice another important skill. That is, drawing structural formulae from names. It is best if you start with the end of the name, with the carbon backbone, and work forwards. Try them independently before checking the answers. The correct structural formulae are shown here for 2-bromo, 2-iodobutane, and 1-fluoro, 2-methyl-cyclohexane. Remember that if there is more than one substituent, they are listed alphabetically.